Hello, friends. How are you? Good. Today we are going to understand approach and methodology for QM pillar, quality maintenance pillar. Now, quality maintain means what? Three steps: achieve quality, maintain quality, and sustain quality. In this approach, one is reactive approach and one is proactive preventive approach. We'll try to understand both. Now, reactive approach means happened defect, happened customer complaint, happened field failures, happened warranty claims. We'll start with happened customer complaint. The first logic is to be kept in mind. Happened customer complaint means our product, when it goes to OEM, there is some complaints registered about our product. The first logical thing in mind is some gap is in our final inspection. That's why defective product went to customer, that is OEM. So while studying this complaint, we must first relook at our final inspection. And in our final inspection, there are four ways to make inspection check sheet in line with inspection agreement with the customer. One is dimensional, second is aesthetic, third is fitment, and four is functional. So revisit inspection agreement, whatever done with the customer. Revisit your final inspection check sheet for dimensional inspection, for fitment, for function, for aesthetic and safety also, of course. If at all there is any gap in inspection check sheet, close that gap, modify your inspection check sheet, train the inspector and display OPL at final inspection stage. This type of complaint has occurred at customer's end. So person who is doing final inspection, he should be well aware of that, well trained, so that from it, not okay job will not go to OEM because of lapse in final inspection. Second is we need to study the root cause, why that defect generated at our end. Do the Viva analysis, take the corrective actions, and link it to sustenance action. So this is how a customer complaint topic is to be tackled by the inspection team, quality team. Second comes field failure. Field failure and warranty, let us take together. Whenever there is a field failure, means what? Ki my product was okay at my end, it was also equally okay at OEM, and then when he went to field, in the field it has failed. Now there are three views to look at this failure. One is some gap in manufacturing defect, some gap in designing the product, and the field abuse. So while studying field failure, first we have to conclude on whether it is a manufacturing defect, whether it is a field abuse, or whether it is a design error. If at all there is a design error, a design person can take the corrective action, modify the design. If it's a manufacturing failure, then we need to correct at the root cause, take corrective and preventive action and sustenance action. And if at all it is a field abuse or field conditions, then we need to put that product for endurance tests simulating field conditions and then cross check whether our product withstands those field conditions. So, field failure, warranty, these defects are need to be studied like this. Now, while studying this field failure, don't use a technique of Viva analysis. Use a technique of fault tree analysis. Means one failure, many causes. Study all the possible causes, happened causes, may happen causes, and take action on it. Then third category comes in-house defects. For that, make a categorization of defects like A type defect, B type defect, and C type defect. Try to understand what is A type defect. A type defect means when production process was going on, okay, like that product was going on, process was going on, but suddenly it started generating defects. Suddenly not okay, started coming. So such defects are A type defect. For that, one defect, one cause, Viva analysis is okay. So study that cause, take a corrective action, that product and process becomes okay. C category defect. C category defect means when the production process started or if at all there is any change in production process, then defect generated. For example, setup change, process changed, parameters changed, startup time, tool change time. So whenever there is any change in the process, the first few defects come, which can come as a defective. Then again you do the fine tuning of process. These defects are called C-type defects. So it's easy to correct. Use Viva analysis technique, take corrective action, sustenance action. Now coming to B-type defect. B-type defect is a chronic defect. Means sometimes it is okay, sometimes it is not okay. We try to analyze and we cannot conclude on its cause. So for that, we have to use a technique of fault tree analysis. Study all possible causes and take corrective actions on all possible causes. Then only this B-type defect can be tackled. It may come to zero, it may not come to zero. If it comes to zero, it's well and good. If it doesn't come to zero, then we have to immediately put their inspection checkpoint and control at the generation point. So this is reactive approach for tackling in-house defect, A type, B type, C type. Lastly, I will say, while reactive approach, please don't ignore material handling and defects coming out of poor material handling. Those defects also need to study, do the fine tuning in material handling, and correct it. And the last category, defect coming into the bought out component. It has to be tackled at receipt stage, receipt inspection stage, and that team has to put efforts to our suppliers so that defective doesn't come to our end. DOL, direct online with zero defect. This is a separate topic how to tackle vendor that we'll discuss separately. Now coming back to proactive approach and preventive approach. For that, there are two, three steps. Let us try to understand them. For any product or process or any line or cell, make a QA matrix, quality association matrix. Means stage by stage study of happen defect as well as may happen defect. Then after that QA matrix, complete line is thoroughly we revisited. We make stage by stage survey for happen defect as well as may happen defect. That all comes to quality association matrix, that is QA matrix. Then for each defect, we either need to do the use Viva analysis technique or fault tree analysis technique. Of course, by categorizing the defect, whether it is A type, B type, or C type, make use technique Viva analysis or fault tree analysis, take corrective actions on happen defect as well as may happen defect. The corrective actions can be quality kaizens, pokayoke, interlocking, and so many. So quality association matrix making and taking actions on happen and may happen defect, that is potential defect. This way you are doing the survey of complete line for that product from first operation to the last operation, and you are trying to set right the process. If at all there are any gaps, those gaps are to be closed. So this step is QA matrix. But now we have to maintain and sustain that. For that, next step comes QM matrix, quality maintenance matrix. Now maintaining quality of product means what? Maintaining quality of the process, maintaining health of the process. In that, for each operation, each stage, there are four M1T resources we are using: material, man, machine, method, and tooling. So each stage we have to define the 4M1T conditions that comes under quality maintenance matrix. So once quality maintenance matrix is prepared, then it is well defined. Then to maintain those 4M1T conditions, we need to put some checkpoints and link to various functions who are responsible to maintain the process. Now to make it easy, the QM matrix, some people call that is a control plan. Some people call it is a IPO, that is input process output. IPO document is a one single page document for each operation or each stage in which the points noted down in the QM matrix are coming at stage level, including which point need to be checked and maintained by whom. For example, if it is a machine or equipment, then PM team has to take the responsibility of checkpoints and maintaining those checkpoints. If it is tool fixture, tool room people have to maintain that tool fixture by checking and maintaining as per the decided frequency. Same with process parameters. It's a in-process quality team's responsibility to maintain the process parameters. When it comes to man, a man necessarily needs to be trained for that operation. And material means if at all some material is coming from our suppliers, then that material has to be defect free. BOP has to be defect free. And necessary gauges used for particular stage. Those gauges maintaining that the responsibility of in-process quality team or gauge inspection team. So this is how, if we set right our product, our lines and our cells for each product, operation by operation, stage by stage. First step is QA matrix, quality association matrix, stage by stage survey of happen defect, may happen defect, potential defect, ABC categorization of each defect, and corrective actions by using highway analysis technique or fault reanalysis technique. Second step is quality maintenance matrix, that is defining 4M1T conditions, operation by operation, stage by stage. Third step is making stage-wise document of IPO, that is input process output, so that all 4M1T conditions are available to check at a glance at stage level, and linking of those 4A1T conditions, check, maintain and sustain, linked to different functions like PM pillar, JH pillar, education training pillar, SHE pillar, whoever it is. So if we keep this approach and adopt this methodology, I'm sure our process can be made capable of zero defect production. Our process health has to be well defined, well corrected, well maintained, and well sustained. So, with this, we started with the reactive approach, happened defect, happened customer complaint, happened field failures, and finally, with this approach, proactive approach, we can make our product and process with zero defects. So this is in short for quality maintenance pillar. I know quality maintenance pillar is a system oriented people. So once we restore the process, correct the process to maintain and sustain, we have to ensure linkage of these things with the various quality systems. Finally, once we correct the process, system should ensure that the process is maintained for capable of producing with zero defect. This is how in short, it's good that you started with one manager model line and started with one product and one cell. So with this understanding, we need to achieve defect free production process for the particular cell. Okay, rest of the things, this was theory, but when we put into the practice, there can be some doubts and some discussions, interaction, so that people will get trained, motivated, and influenced to achieve the task. Thank you very much. Have a nice day.